I know how we love complex fractions. So here we have a complex fraction to work with. This one is going to come up with a really nice little solution. What we need to do is work with our numerator and our denominator separately. The nice thing about this particular complex fraction is the denominator is already a single fraction. So the numerator is what we're going to focus on working with first. And then we can flip the second and multiply or match up the complex fraction like we've done before. So we need a common denominator. We can't divide until we have a single fraction on top and a single fraction on the bottom. In order to get a common denominator, we need to multiply our first fraction by the second denominator. So here we're just multiplying by x over x. And parentheses are important here. And our second fraction by x minus 1 over x minus 1. We have to use fancy form of 1 here because we don't have an equal sign in our problem. We're simplifying, not solving. So we have to kind of switch modes from where we were on the last problem. We're going to have a common denominator now of x times x minus 1. And our numerator is x minus 1 times x minus 1. I know that's super repetitive. You have to make sure you capture that negative in the middle there. Okay, now we just need to simplify on the top of our new fraction. Distributing your negative through, negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. And your x's cancel there. So the numerator of our fraction is x times x minus 1. The denominator was 1 over x squared minus x. So if we go ahead and work with that a little bit, we can factor out an x. So we have x times x minus 1 there as well. Oh my goodness. This one is beautiful. So our whole fraction now, here's the bottom of our fraction. Here's the top of our fraction. And they're exactly the same. So if you would like to stack those, and group them, this times this over this times this, what you end up with is 1x times x minus 1 over itself. I know it seems way too simple, but it's not. It's a good one. If you don't like stacking and you want to do flip the second and multiply, the bottom is the one that you end up flipping. Or you can recognize that you have the exact same terms and anytime you divide something by itself, you get 1. That's a pretty one. Okay, you almost made it through the first section of your exam review. So we have a factoring problem to do next, factor and cancel. The thing that you need to be careful with this one is that you are going to end up with some terms that cancel. You're just going to need to factor out a negative. So y squared minus x squared is a difference of squares. So that's going to give me y plus x and y minus x. Don't be scared of multiple variables. 5 times x minus 5 times y, we can GCF out a 5. Now is a good time to take a look at your possible solutions. So in all of our solutions, we don't have a negative in the denominator. If we did, I would go ahead and factor out a negative with that 5. But since I'm trying to match one of our solutions over here, I need to factor out a negative in the numerator. What I want to match are these two. Right? What they're off by is a factor of negative 1. That's how they're different. They're different by a negative 1 there. So I can switch these. I can switch the one on top by factoring out a negative 1 and switching the signs. When I factor out a -1, the y becomes negative and the x becomes positive. So I'm just going to rewrite. -y plus x I can write as x minus y. Oops. Now I can cancel. So I have -1 on the top. Y plus x is the same as x plus y, and just a 5 in the denominator. Beautiful. All right, one more, and it's a word problem. You just have to take it a little bit slow when you're reading the word problem. It's not that complicated of one. So when the square of a number is decreased by 9 and then divided by 6 less than twice the same number, the result is, okay, so we're going to have a fraction that we need to simplify. So let's just start from the beginning again. The square of a number, I'm going to make that x squared. That is the square of a number. A number is going to be x. Decreased by 9 means I'm going to say minus 9. And then divided by, so that's where my divided by symbol is going to go, or my fraction bar. 6 less than twice the same number. So I'm using the same number, so I don't have two variables here. I still have x, and it's twice x, and 6 less. The thing with subtraction is a lot of times the way it's written, you have to kind of think of it backwards. So 2 times x minus 6 is the same as 6 less than twice the number. So I have x squared minus 9 over 2x minus 6. And if I had given you that, you could have factored and canceled so quickly. It's good to look at some word problems. So we're going to factor out a 2. And that's something that you might see on the ACT or the SAT. You might see some word problems like that where they try to trip you up with the wording really instead of the math. So here, what we end up with is x plus 3 divided by 2. So let's try to match that. I'm just going to try to get rid of options first. 4 less than? No. I don't even have to read the rest of that. 1/2 of 3 more than. Okay, that's possible because I have that 2 on the bottom, and dividing by 2 is the same as multiplying by 1/2. 1/3 of, okay, again, just like the 4 less, 1/3 of, no. 3 more than twice the number. 3 more than twice, well, I don't have a 2x, so it can't be that one. So let's try to make it match this 1/2 of 3 more than the number. Well, again, dividing by 2 is the same as multiplying by 1/2. So I could write this as half times x plus 3. And that will match that description. Not a hard problem except for the wording. All right, I hope this was helpful.